Okay, we're in section 28. We're going to do the homework. I'll switch to the whiteboard now. Again, we're in section 28, and we're doing the homework for section 28 now. Certainly, as I do these problems here, I'm not going to say there's only one way to get an answer on these problems over here. Certainly, as I present it to you, you might say, I want to try something different, and we're not going to deny that. So this over here, what I would recommend you do, give me 1 second, I'm going to get my pen out, is it says convert the rectangular coordinate to the polar coordinate with the understanding that r is going to be a positive number and that theta will be between 0 and 2 pi. Make your choice of theta and the correct, okay, sure your choice. Okay, yeah, we can do that. So first one, minus 1, 1, first thing I would do. And again, I'm not saying you would do this. I'm just saying the first thing I would do is I would visualize it. And the point is minus 1, 1. So that's right over here. So I'm going to say that's fairly easy. What do I notice? The angle theta here. And again, the reference is a 45-degree angle. So the angle is 135 degrees. Again, I should put it in radian. That's going to be 3 pi over 4. And what's the directed distance r? Well, we need a positive number. So if you thought about it, it's a 1, 1, and this would be root 2. So the r would be root 2. Right, let me write it down as an ordered pair. The ordered pair is going to be r, comma, theta. And for the first one, the r is root 2. And the angle is 3 pi over 4. Look at the key, make sure you're matching that. All right, let me do B. Again, the first thing I would do, I would visualize it. And what do you get over there? Well, it's root 3 minus 1. So maybe over here somewhere. And the angle's like this. What's the reference angle? And again, these are things that you learned in math 120. So the reference angle would be 30 degrees. Let's see what we got up here. So the angle theta is going to be 330 degrees. Well, the theta is actually 11 times 30 degrees. And what's 30 degrees in radian? It's 11. That would be pi over 6. So the angle theta is 11 pi over 6. Now the reference triangle, looking at it, I just want to point out, looking at over here, root 3, 1. What's the hypotenuse over there? It would be 2. So the r is 2. Let's write it down as an ordered pair. And the ordered pair is written down as r, comma, theta. So what's the r? The r is 2. The theta is going to be 11 pi over 6. Again, my recommendation, look at the key. If you make a mistake, correct it, which I will do. All right, letter C now. I'll put this down for you. That's going to be 2, 8, and 2, 8 is probably about here somewhere. And the problem with this is it's not a known reference triangle. When you took Math 120, the known references were 30, 60, or 45. So now we got something that's a little bit different over here. So I have to use the arctangent function. So theta is arctangent of, what's that going to be? Well, it's going to be 8 over 2, which would be 4. Let me write that down for you. No, you're not expected to do that on a calculator, but this would be 2. So, the next thing is the r. What's the r going to be? X squared. Whoops, sorry about that. X squared plus y squared. So r squared is equal to 4 plus 64, which is 68. And the r would be equal to the root of 68. I'm sorry, 68. And that's going to be 4 times 17, right? Let me just check that. 40 and 28, 68, yep. And the square root of 4 is 2. And then you get root 17. So again, it's going to report it as r theta. What's the r? The r is 2 root 17. Again, we'll check this in the K. And the angle is arctangent of 2. All right, let's take a look at the K, see how we did. And I made a mistake. Let's see where I made a mistake. Oh, I see it now. So I'm going to correct it and get my eraser out. And I just misread the number. And I say no excuse. You have to correct your mistakes. That was actually 2. And 8 divided by 2 is 4. My eraser out again. Now you might say making mistakes slows you down. It does. It definitely slows you down. And let me go back over here. And let me correct it in my answer. And I'll put the correct answer in 4. Okay, 8 divided by 2 is 4, right? So let's see what we got over there. Yeah, we did it okay. We got the 2 root 17 and arctan 4. All right, not number, but letter D. Again, my understanding about letter D is I need to visualize, and that's going to be, -6 minus 5. I'll put this over here, maybe something like this. So I know the angle's like this over here. All right, that's the angle theta. So what I got to do is I got to get the reference angle. And the reference angle, I'm looking at, basically a positive triangle with sides, right? And that's going to be arctan. This is the reference. What do you mean by reference? Is this over here? All right, what's that going to be? Arctan of 5/6. All right, so what's the angle theta? Well, if you thought about it, it's going to be pi. I want to point out what I mean by that. I have to go pi, and then I got to go that reference, which is plus arctan of 5/6. Again, we'll check the key later. What's the r? Well, r squared is equal to x squared, which is 36, plus the y squared, which is 25. And what's that going to be? 51, let me see, 61. All right. So what's the r going to be? Root 61. I'm write this down. Again, the answer is going to be written as r, comma theta. So it's going to be root 61, comma pi plus arctan. I'll write it this way over here, 5/6. Again, I'm doing homework. I realize this is a chicken scratch. Everything's been typed up for you. Let me make sure I read it right. That arc. Yeah, I did. So things are looking good. All right. So I'm going to go to the next one. Next one, you have a polar problem, and they want you to write down the Cartesian point. All right, convert the polar to Cartesian. Fairly easy to do. I want to point out, I'm not going to visualize this one, but you can. What's x equal to? R cosine theta, and y would equal r sine theta. All right, so let's put a down. A is fairly easy to do. X will equal, what's r? R is 2. And what's a cosine of pi over 4? 1 over root 2. What's this going to give me? Root 2. Let me do y. What's that going to be? 2 times the sine of 45 degrees, which is 1 over root 2. That also gives me root 2. So on the Cartesian plane, the point is root 2, root 2. All right, let's look at the k, and I'm seeing that there. All right, let's go to the next one. This is going to be b now. B is also going to be easy. Again, I'm not visualizing it. What's the r? The r is 3. And then I got to put down, excuse me, the cosine of minus pi over 3. We'll do that in a second. And y is going to be 3 times the sine of minus pi over 3. All right, now pi over 3 is going to be a 60-degree triangle. So that is going to be 1/2 then. So I get 3 halves. And this will be 3 times, let's see, minus root 3 over 2, right? And what do you get over there for the ordered pair? 3 halves minus 3 root 3 over 2. All right, let's look at the k and see how we did. I'm seeing that there, and I'm seeing that there. Let's go to the next one, which is, let's take that look at that. That's x equals, this is c now, we're doing c. What's going to be r is going to be -1 times the cosine of 7 pi over 6. And y is equal to -1 times the sine of 7 pi over 6. So I kind of want to remind you that, certainly it may be unfamiliar to you, or you might say it's too long ago to remember anything. Convert this to a degree, and I want to get the reference triangle for you. So that cancels off, you get pi, that's 7 times 30 degrees, which is 210 degrees. So why would I do that? I want to visualize it. That's 180. The reference is 30 degrees. So I'm going to write down the triangle for you. This would be 1, this would be root 3, and that would be 2. These things have signs though. And what I mean by that, it's -1 times the cosine. Well, the cosine is going to be -1. I'm sorry, minus root 3 over 2. We'll do that later. This one's going to be -1 times -1/2. So what's the point going to be? Well, it's going to be root 3 over 2, comma 1/2. All right. So let's see if I did that right. And I'm going to go over here. Again, what do I mean by looking at the k? And I want to see if I did that. root 3 over 2, 1/2. Looking good. All right, let me go to D. D is, again, I'm going to write this down. What's x going to be equal to? R. What's R? R is 5 times the cosine of 2. No, I can't do the cosine of 2 in my head. I could approximate it, but we're not going to approximate these. And if we are, we're going to use a calculator to do that. Then the other one's going to be 5 times the sine of 2. So what's the coordinate going to be? 5 cosine of 2, comma, 5 sine of 2. Let me take a look at the answer key. 5 cosine of 2, 5 sine of 2. Not so bad. All right, let me go to number 3. And number 3 says, find the equation in polar coordinates of the line through the origin with slope 1/4. Well, what I would do over here is I have to visualize this one because I'm kind of confused by it, but it says there's a line through the origin, and that line looks like this over here, and it's got a slope of 1/4. What does that mean? Well, if I drew a triangle, this would be 1, this would be 4. All right, so what's the theta going to be? Well, the theta is going to be the arctangent of 1/4. And this is the polar equation now. All right, there's other ways to do that. You get the equation of the line and you can convert it. I think it's a little more difficult, but if I did that, let me write down when I get over here, y equals 1/4 of, let's see, 1/4 of what? Oh, 1/4 of x. And then what do? Multiply both sides by r. And none of them do that. I'm going to write these down over here. X equals r cosine theta and y equals r tan. I'm sorry. I'm thinking forward and I shouldn't do that. Sine theta. So let's write this down. This is going to be r sine theta equals 1/4 r cosine theta. Well, what I could do is divide both sides by r, so I get sine theta equals 1/4 cosine theta. And then what I would do is I'd probably divide both sides by cosine theta, and I would get tangent theta equals 1/4. Now, someone could say that's also an equation of that line, and I'm going to agree it is, but typically we would say theta equals the arctan. And again, you don't have to do this two ways, but I'm saying all roads lead to the same answer. And I got the answer over there. All right, number 4, I'm going to have to pull this on the side. And sorry about this. I'm going to pull this stuff around and get rid of all this stuff over here. And I'm going to work on this. And again, if you can't remember the instruction, reread it. And this wants me to write down the a Cartesian form of it. And I would actually prefer to write down a Cartesian form. But let me write this over here. R equals 9 over sine theta. And then I would have r sine theta is equal to 9. And you should recognize that as an equation y equals 9. What is that? It's basically a line. It's a horizontal line. So let's do this one over here. This is r equals 9 over cosine theta. And then you get r cosine theta is equal to 9. What do you get over there? Well, r cosine theta is x equals to 9. And let me see. I have to go back to the question because I can't remember if that's what they said. Oh, they said graph it. So graphing this guy over here is really simple. The first one graphs out as y equals 9. And the second one graphs out as x equals 9. Fairly simple. Let's go to the next page. I did graph that. And I see this over here. It's graphed on polar paper, by the way. But polar paper is just an overlay of Cartesian paper. So this looks good. So I did okay. Let's go to the next one. Next one says convert r equals 7 to an equation in rectangular form. And by the way, there's many ways to do this. I'm not saying there's only one way to do it. So let me write this down. R equals 7. What I would probably do is, you could visualize it. And this is a circle of radius 7. So it's a circle, radius equals 7. You could visualize that. If you want to write that down, what's it going to be? X squared plus y squared is equal to 49. And that's the equation of that circle. If you prefer, you might say to yourself, I don't want to visualize it. Well, if you didn't want to visualize it, what I would probably do is square both sides. You would get r squared equals 49, and r squared is x squared plus y squared is equal to 49. So a visualization is not important. You could do that either way. All right, it's number 5. So far, they're kind of confidence builder problems. What I mean by that is stuff that you've seen in Math 120, right? So this one says convert And again, I don't want to draw this one, but you could. And let me put this over here, r equals 2 sine theta. I would probably multiply both sides by r. You would get r squared equals 2 times r sine theta. What's r squared? It's x squared plus y squared. And this would be 2 times, well, what's r sine theta? That's going to be equal to y. So what do I get over here? It's an equation of a circle. By the way, this is a fine answer. If you want to put that down, I'm just going to rewrite it. So it's going to be x squared plus y squared minus 2y equals 0. I'm going to complete the square. Half of minus 2 is minus 1 squared plus 1. And what do I get over here? X minus 0 squared plus y minus 1 squared equals 1. So this is a circle. Its center is going to be 0, 1, and its radius is going to be 1. This is easier for me to graph than it is the polar form, but it's the circle. All right, let's see if they got the same answer. And I'm looking at that over here, x squared plus y squared equals 2y, or written in standard form, x minus 0 squared plus y minus 1 squared equals 1. All right, and it does go on to say it's a circle radius 1, centered at 0, 1. Okay, let's do the next one. Again, fairly simple. Again, these are confidence builder problems, and it's going to be 4 cosine theta. Again, I would multiply both sides by r. You would get r squared equals 4 r cosine theta. This is x squared plus y squared is equal to 4x, right? So what do you get over here? That's a fine answer if you want to use that. I'm going to write it in standard form. It is a circle, by the way. Minus 4x plus y squared equals 0. Half of minus 4 is minus 2. Square it, you get plus 4. This will be x minus 2 squared plus y minus 0 squared is equal to 4. This is a circle. Its center is 2, 0, and its radius is 2. Let's look at the key, see how we did. I'm seeing this, and I'm seeing saying there's a circle radius 2, center to 2, 0. All right, number 8, I'm going to write it down for you. This is going to be r equals 8 over sine theta. You may wonder why I do that. Cosecant is too difficult for me. Then I would get rid of the fraction. And once I do that, I start to realize I'm in familiar territory. What's r sine theta? It's y. So y equals 8. All right, what is it? Horizontal line. By the way, refer to this as deja vu. Your exams are pretty much going to be deja vu problems for you. What does it mean by that? They're going to look just like, what you've been given in homework. All right. And that's going to be true throughout I'd say your tenure at Essex. When you transfer to another school, that's going to change, by the way. What I mean by that, they're going to start to give you exams where they're starting to get you to synthesize the material. In other words, questions that really weren't asked before. All right, let's look at number 9. I would clear the fraction. And what do you get? R cosine theta minus r sine theta is equal to 2. And by clearing the fraction, I said this is very familiar to me. What do I get over here? X minus y is equal to 2. This is an equation of a line, very simple. All right, let's go to the next page, see if we got it right. And I guess they solved it, right? So what they solve it for? Well, that'll be y equals x minus 2. They just solved it. All right, it's a line, slope of 1, y-intercept of minus 2. Fairly simple. All right, number 10, we're starting to get into the calculus. All right, so we derived this formula. I'm hoping you paid attention to the derivation of that formula, but the bottom line, that form has been derived. How was it derived? Well, we said x was written this way, y was written this way, and then, writing this over here, basically what I'm doing is I'm doing x prime with respect to theta over y prime with respect to theta. Now, I would say that would be a good way to remember that formula. However, it's been given to me. So I'm just going to, basically do it. And what do they want? They said, find the slope of the tangent line. Oh boy, I got to do this over here. So what do I got to do? You could graph it. I'm not saying otherwise, but I really need to find out what dy dx is. All right, and put this over here. So what do I have to do? And I have to write this down for you. So, I'm going to write this over here, f of theta, that equals 2 theta. All right, and that's not so bad. I think I can handle this. And I know it's difficult, but I don't enjoy doing this either. I'm looking at the formula. I'm going to write this down. What's f of theta? 2 theta times the cosine of theta plus f prime with respect to theta. That's going to be 2. I'll write this over here. F prime of theta is 2. I'll write this over here. 2 sine theta. All right, let's go to the bottom. Well, it's going to be 2. That's F prime of theta times cosine of theta minus F of theta, which is 2 theta, times the sine of theta. And I'll put this over here. Now, what do they want to know? They want to know dy dx at the point where theta is equal to 3 pi over 2. Let me see if I can do that. I got to plug it in now. It's work, no doubt about it. So 2 times that angle would be 3 pi. The cosine of 3 pi over 2 would be 0, plus 2. The sine of 3 pi over 2 is minus 1. Let's go to the bottom. 2 times the cosine of 3 pi over 2 is 0, minus, well, 2 times 3 pi over 2 is going to be 3 pi. And then what do you get? The sine of 3 pi over 2 is going to be minus 1. Got to be careful. Let me get my eraser. I want too big of a fraction bar there. And what do you get on top? Minus 2. And what do you get on bottom? You get 3 pi. So I got my slope. And this is m tan at the point where theta equals 3 pi over 2. Now I need the point. And why is that? It's going to be y minus y1 equals m x minus x1. All right. So how do you get the point of that? And you know that I'm not going to be easy for you, but I guess I have to get the point. And let me just make sure I'm doing this. I'm going to look at my key, and I want to make sure I got the right answer over here. And m tan I got this over here, and I'm gonna get the point now for you. And someone says, how do you get that point? Well, I have to get the point, and let's see what the point would be. X is going to equal r cosine of theta. All right. And y is going to equal r times sine of theta. Well, you know what nice about this problem over here? I know the angle. And what's the angle going to be? It's 3 pi over 2. So if it's 3 pi over 2, the cosine of 3 pi over 2 is going to be 0. So I don't care what r is. This will be 0. Now this one over here, I'm going to write the r down, but I'm going to get minus 1 over here. Now someone says, what's r? Well, r has been given to you as 2 times theta. So what's 2 times theta? Well, if theta is 3 pi over 2, that would be, r would be equal to 3 pi times minus 1. So what do you give there? Minus 3 pi. All right, we have to turn the page to get the answer over there. So it's going to be y minus, minus and minus 3 pi is going to be plus 3 pi equals the slope. That's going to be minus 2 over 3 pi x minus 0. I want to simplify that, but I'm going to be honest with you. This is a good answer. You can write that down. If I'm going to solve for y, it's going to be minus 2 over 3 pi x minus 3 pi. All right, let me go to the answer key. I want to make sure I got that answer. I did. They graph it out for me as well. And you don't have to graph it. At least I don't think they asked you to graph it. Let me make sure of that. No, they didn't ask me to graph it. Someone says, how'd you graph that? The machine did that. All right. Of course, I had to put the input in the machine. I didn't say, hey, machine, draw me that picture for me. I had to know it worked the machine. All right. So this one over here, it says, find the rectangular coordinates of the point. And they give me a picture. I want to point out, I'm going to look at the picture for you. This is the picture. I'm glad I got a picture. And what they say is, at the points where the horizontal and vertical tangent lines. So what I want to do is I want to talk about symmetry in the curve. I'm going to say there's going to be a horizontal tangent line here, but these things, they're all symmetric. All right. And there's going to be verticals over here. There's a vertical there and a vertical over here. All right. So what do I want to do? I want to do that, but I got to go through the work with you. And certainly I'm going to write this down, and I'm just going to stick in the first quadrant. All right. So I'm going to stick in the first quadrant like this over here. All right. So this is the first quadrant. So my question over here is I want to figure out this point here, and I want to figure out this point over here. All right. Let's take a look at it. So if I'm sticking in the first quadrant, the equation is going to be r equals 9. I'm taking the square root times the square root of cosine 2 theta. All right. It looks a little difficult, doesn't it? So what do I want to do? I'm going to say r is a function of theta. And that's going to be 9 root cosine of 2 theta. So I'm going to put down dy dx. Remember, the formula has been given to you in the prior problem. If this is an exam question, you need to look it up. Just look it up. That's all you have to do. Let's write this down. F of theta, that's going to be 9 root cosine 2 theta times cosine of theta. I'm not done yet. All right, I'm going to put the bottom down. And now I keep going to the top. So what do you get over there? That's going to be f prime. Oh boy, that's going to be tough to put down. 9. And then I'm going to get 2 root cosine 2 theta. Over the inside is going to be minus sine 2 theta times 2, right, times sine of theta. This is kind of nightmarish, isn't it? I'll clean it up later, by the way. Let's keep going. What I'm going to do in bottom, I'm going to put f prime down now. Well, I just did that, didn't I? I'll put it down again. 9 minus sine 2 theta over 2 and 2 root cosine 2 theta times cosine theta. Don't be alarmed yet. We're almost there. And it's going to be minus 9 root cosine 2 theta. And again, we're using the formula. And then it's going to be sine theta. All right, this is like a nightmare to me. But I got to be honest with you, there are no nightmares. So I'm going to multiply top and bottom by the cosine of 2, the root of cosine 2 theta. And what would I get over there? Well, and again, this is the top. I would get 9 cosine 2 theta cosine theta. Wow. Minus 9 sine 2 theta sine theta. I got to be careful. I'm going to make sure I did it right. The 2's cancel. Yeah, I think I did it right. I'll look at the key later, though. Mistakes happen. So what do you get over here? Minus 9 sine 2 theta cosine theta. Let me make sure I did that. Yeah, all right. Okay. Minus 9 cosine 2 theta sine theta. All right, I'm going to do something crazy. I'm going to divide through by 9. I'm going to divide through by minus 9. And what do you get? Sine 2 theta sine theta minus cosine 2 theta times cosine theta. And on bottom, you're going to get 9 sine 2 theta cosine theta plus, I'm sorry, I divide through by minus 9. So let me just get rid of that 9. And that would be cosine 2 theta times sine of theta. All right. And this is the derivative dy dx. I'm going to look at my key, by the way. That's on the next page. I'm not going to look at the key. I'm going to do my point now. All right. So I'm going to say, when does dy dx equal 0? Well, it equals 0 when the top is equal to 0. So I'm going to write this down now. So sine of 2 theta sine of theta would equal, oh boy, this is going to get tough, cosine 2 theta times cosine theta. All right. Boy, that looks like work, doesn't it? And let's put this down. Let's see if I can do that easily. You know, I'm gonna look at my picture too, see if it's easier than I think it is. It's certainly an angle between 0 and pi over 2. I have 2 theta over there, so. Let me see this over here. So sine of 2 theta is 2 sine theta cosine theta times sine theta. I realize this is work. And sometimes I don't want to do that work. Not much choice though, do I? And this is going to be cosine 2 theta cosine theta. Well, I can divide through by cosine theta. Let me put this over here. So 2 sine theta squared. I'm dividing both sides by cosine theta. And you get cosine 2 theta. You get the idea what I'm doing? Let's see if I did that right. 2 sine squared, right there, cosine. Not so bad. What do you get over here? 2 sine squared theta. Now I'm going to say cosine 2 theta is going to be 1 minus 2 sine squared theta. So this is going to be 4 sine squared theta equals 1. Geez, getting much easier. Sine squared theta is equal to 1/4. Remember, I'm sticking in the first quadrant. So I'm just going to look at this over here. Sine theta is 1/2. And again, this is going to give you that angle where the derivative is 0. And that's pretty easy to do, by the way, because theta would be what number? Would be 30 degrees. Let me make sure of that 30 degrees would give me, 1/2, which is pi over 6. All right. Now, granted, I realize a lot of students are looking at this and they're saying this is just too much work to get through. So I know the point here, let me see what they want to get. Yeah. And the point over here is going to be, this one over here is pi over 6. We'll get the point later. I want to do the bottom now. All right. And the bottom is going to be a similar type problem. I'm looking at the bottom now, and I'll write this over here. I'm looking at the bottom. And for it to have a vertical tangent, that's got to be 0. So I'm going to set the bottom to 0. All right. So I'm looking for the vertical tangent now. So it's going to be sine of 2 theta, cosine theta. And that would equal the opposite of cosine 2 theta sine theta. Let's go through it. I'm going to do the same thing I did before. And I'm going to write down 2 sine theta, cosine theta. I'm just using a density I learned in Math 120. This minus cosine 2 theta sine theta. I can divide through by sine theta, by the way. And what would you get over there? You would get 2 cosine squared theta, and then you would get minus cosine 2 theta. What do you get now? 2 cosine squared theta, and this over here would be minus 1. I'm sorry, I went too quick there. Cosine, 2 cosine squared theta minus 1. And what do you have there? You would get 4 cosine squared theta is equal to 1. Cosine squared theta is equal to 1/4. And what would you get over there? You would get, again, it's just in the first quadrant, by the way, you get cosine theta would be 1/2. And that would be at 60 degrees, right? Which is pi over 3. Let's write that down. Well, we have a picture. Where am I? And this theta over here is pi over 3. All right, we're going to go to town in this one over here. And by that, what I'm saying over here is, I'm going to look at it. I remind myself what I'm doing over here. That coordinate system. I can write this down now. So r squared. I'm going to do pi over 6 first, by the way. And what are you going to get? 81 cosine 2 times, again, I'm using theta equals pi over 6. Cosine, that would be pi over 3, right? That would be 81 times, make sure I'm doing this right, cosine of 2 theta, I'm doing pi over 6. And I can make sure I'm doing that right, pi over 3. That's 60 degrees, that's 1/2. So R here, I'm just doing the first quadrant, all I'm doing is going to be 9 over root 2. So this point over here, the x coordinate, I'm sorry, the R, what am I saying here? Yeah, the R is 9 over root 2. All right, so did I need to do that though? Let me see, find the rectangle. Oh, they want to find the rectangular coordinates. So what do you get over here? X equals R times cosine pi over 6. I'm sorry, what's R? It's 9 over root 2. Sorry about that. Yeah, a lot of work though, I realize that. Cosine of pi over 6, that's 30 degrees. Root 3 over 2, right? 9 root 3 over 2 root 2. Oh, it's a nasty looking number. Let's do y. And that's going to be r, which is 9 over root 2 times the sine of pi over 6. Pi over 6 is a 30-degree angle. And that's going to be a half. So 9 root 2 times 1/2, which is going to be 9 over 2 root 2. So I got this point over here. And this point over here is going to be 9 over 2 root 3 over root 2, comma, and the other one was 9 over 2 root 2s. By the way, you get the other points too. I just want to go to the next page, and I want to just make sure I haven't made any egregious errors. And there's a lot of work over here. So let's see if I got the point. And XY. I want to tell you the point I wrote down over here. I had to clean it up though. So 9 root 3, 2 root 2, multiply top and bottom by root 2, you would get 9 root 6 over 4. And the other one's going to be 9 root 2 over 4. So I'm seeing that point over here. And by the way, when I say that, there's going to be 4 points like that, but they really have, perfect symmetry. So what I'm doing is, if I know one's in the first quadrant and it's here, what do I know about the other one? Well, it would be this one here, this one over. Whoops, sorry about that. So if I have this one, I have the other one. Let me do this one over here. Well, this one would be, let's see, that one there, and then this one over here would be that one there. So if you found this one, you found these 3 over here. Now let's do the vertical tangent. Let me see if I got that. And I got to get there. Did I put those down? I don't know if they put them down. Let's get them. Let's go back over here. And I just wanted, did I do it? I can't even remember. Yeah, I did it over here. That was pi over 3, right? So let's write this down. Again, I'm doing this point over here. There's going to be 2 points now. They should be easy points to come up with. So let's see, x would equal r times the cosine of pi over 3, and y would equal r times the sine of pi over 3. All right, so let's see if we can do that. And what's the r again? I got to remind myself. The r is 81. I'm sorry, not 81. I'm sorry about that. It's 9 root of cosine 2 theta. And I want to remind you that theta is pi over 3. So it's going to be 9 root cosine. I think I might have made a mistake somewhere. 2 times pi over 3. think I might have made a mistake somewhere. And I got to figure out where I made a mistake. There's so much work, you kind of forget where you made mistakes. So let's see if I got the bottom right. I'm going to look at my derivative, see if I did that okay. Sorry about this. I know I'm going around a lot. Yeah, I got the bottom right. Let me see if I got the angle right. Let's not look at this. Pi over 4. And did I do the other one? Did I do the verticals? I don't know if I did the verticals. Let me read the question. Maybe I'm making up the question when I'm not even reading it. It does say vertical tangents. Let me just take a look at that. I don't think I did the verticals. Curl symmetry, 4 points. Get vertical tangents, all very symmetric. R greater than 0. Next, look easy on vertical tangents. Look easy, they occur. But it's true, they do look easy. Let me write that down then. Maybe I shouldn't go through that derivative nonsense. R equals, I'm sorry, X equals R cosine theta and Y equals R sine theta. And it's true. Let me point out what I mean by that. If I'm looking at the picture, over here, the Y is clearly 0. Let me go back over here. So I'm going to say that it's a little bit easier to deal with this. I didn't think about it, but when would that occur? When theta is equal to 0. So what would the cosine be? X would be equal to R, because cosine of 0 is 1. What's R? And we're at 0. And what's the R? If I recall, the R was equal to 9 root cosine 2 theta, and we're at 0. So cosine of 2 theta, it's still going to be 1. So it's going to be 9. Yeah, that's what it is. It's 9. I got it right over here. And again, I'm looking at that. Let me go back to my picture. And these things over here, it's 9. And this one over here, when I say that the X is 9, the X would be minus 9 over there. All right. So I drew the picture of it. Someone says this picture got a lot of colors in it. Yeah, got a lot of colors in it. So that's about it. Thank you for your attention. The last problem, I want to be honest with you, a little bit tough how to think about it. And that's good when you're getting homework. The initial one's really just, it's almost like mindless activity. But then you're in I'm not going to say a rut, but you get to a problem where it requires some thinking. Thank you for paying attention, though.